Your homework for tonight, 3.4, is on WebAssign. So you're going to enter everything in WebAssign, show your work, put the screenshot at the top like normal, but it is not due until Thursday morning. So if you want to work on some of it tonight, you'll have the class period tomorrow, but remember, class period tomorrow is short. Each class is only like 30 minutes. So that's why we're giving you that class period to work on it, and then we'll start on the review. So 3.4, we're going to do a majority of 3.4 today. Then when we come back from Christmas, we're going to do the rest of 3.4 and 3.2. Kind of goes out of order, but we're going to leave the graphing and the calculator stuff till after Christmas, just so we're not cramming it all in at one time, and then you guys don't have half, in the midterm and half not. After your test Tuesday, we have Wednesday, Thursday, and then we start midterms. So if you're taking the midterm, you really need to look at the midterm review that we do. You need to work through it. You need to ask questions those Wednesday and Thursday that were in here. And then actually on the review day. For this class, we review on Friday the 13th. And then you take the exam on Monday the 16th. So just be aware. All right. We're going to talk today about the factor theorem. I brought this up yesterday. And we discussed that if f of x equals 0, then the divisor is a factor. What that means is when you use synthetic division, with a number, and the remainder is 0, then that number is a factor. What's another way to say is a factor? Is a 0, a solution, a root. What's another way to say that? What's one more way? X-intercept. Good. Where the graph crosses the x-axis. So what we're going to do today, guys, is really quite simple. We're going to be doing synthetic division. We're going to keep doing synthetic division with different factors, you'll see, until we get 0 as a remainder. Then we're going to write our resulting polynomial and try to factor it. You'll see exactly what I'm talking about here as we go through. So the first few are a little different than the last few. Number 1 says, okay, here is the polynomial. Right? Do you guys see this? 6x cubed plus 19x squared plus 2x minus 3. How many answers should we get? 3. How do you know we should get 3? Because that's the highest exponent. Now, we don't know if they're all real. We don't know if there's 2 imaginary. We don't know if they're all pretty, that sort of a thing. But we do know that there's 3 hidden in there. So they're telling us one of them. They're telling us that one of the x-intercepts is x equals negative 3. You guys see that? So what do I do with that? They're telling me that negative 3 is a factor. I got to find the other ones. What do I do with that negative 3? Yep, we're going to use it as our synthetic division. So I have negative 3, and then I write out my coefficients. What are my coefficients? 6, 19, 2, and negative 3. Perfect. How do we synthetically divide, guys? Bring down the first term, and then what? Multiply to the corner. So 6 times negative 3, negative 18. 19 and negative 18 is 1. 1 times negative 3. 2 and negative 3. Negative 1 and negative 3. And then negative 3 and 3 is... So are you correct? Did you prove? Oh, yeah, it is a factor. We saw that. Okay, perfect. So what is this that's left over? That's your resulting polynomial. You just did division. We started off with x cubed. So what does your answer start off with? X squared. This is my x squared. This is my constant. Sorry. This is my x. This is my constant. And this is my remainder. So how would you write that polynomial? 6x squared plus x, God bless you, minus 1. All right, we'll set equal to 0. Now, there's 2 things you can do here. And we're going to learn this in a little bit. You can do what's called the root theorem, P over Q. Or when you get to this point, we hope and pray that this factors. After you do synthetic division once and you find a factor, you hope that what's left over factors. Does this? 6 times negative 1 is negative 6. Are there factors of negative 6 that multiply to give me negative 6 but add to give me positive 1? What are they? Negative 2 and positive 3. Okay, you can do my shortcut or you can do the grouping method. I'm going to write out 6x squared minus 2x plus 3x minus 1 equals 0. So we're going to group the first two. What can I take out of 6x squared and a negative 2x? 2x, okay. And then what are we left with? 3x minus 1. Okay, what can I take out of 3x minus 1? A positive 1, perfect. And I'm left with 3x minus 1. So I can rewrite this as 3x minus 1 times what? Times what, guys? 2x plus 1. Good. Factoring, y'all, is never going away. Can I solve these two? Yes. So 3x minus 1 equals 0. 2x plus 1 equals 0. So I discovered the other two intercepts. I have one at x equals what? 1/3. And I have one at x equals negative 1/2. Good. We found the zeros, the solutions, the roots. There was 3 of them. We said at the beginning there was going to be 3. If they asked you to find the x-intercepts, you guys just did that. But how would you write the x-intercepts? How would you write the x-intercepts? What was the first one we found? Negative 3. An intercept is always an ordered pair. So negative 3, 0. Then what? 1/3, comma 0, and negative 1/2, comma 0. This whole lesson is going to center around factoring. If you don't know how to factor, you're going to be sunk. We've talked about factoring since the second day of school. Very, very big concept in Algebra 2. All right, look at the next one. They're telling us, first of all, I look at this and I say, oh, okay, I should have how many answers? 3. Highest exponent tells me how many answers. They're already telling me one of the factors, but they didn't say x equals. They said one of the factors is x minus 1. So how do I figure out what to use for synthetic division? Set it equal to 0. Good. So x equals 1. So I'm going to do 1 and then write out my coefficients. So I know one of my zeros, one of my solutions, one of my roots is x equals 1. So I have 2, negative 3, negative 5, and 6. Yeah? How do we synthetically divide? Bring down that first term, and then we multiply to the corner. 2 times 1 is 2. Negative 3 and 2 is negative 1. Negative 1 and 1 is negative 1. Negative 5 and negative 1 is negative 6. Negative 6 and 1 is negative 6. 6 minus 6 is 0. If you don't get 0 here, when they tell you something is a factor, go back and check your math because you did something wrong. So we're good here. So what's left over? What's my resulting polynomial? 2x squared minus 1x minus 6 equals what? 0. And what do we hope happens here? We hope it can factor. Are there factors of negative 12 that multiply to give me negative 12 but add to give me negative 1? What is it? Negative 4 and positive 3. Good. What would happen if this didn't factor? We'd have to do the quadratic formula. Perfect. Since the highest exponent is 2, you just do the quadratic formula. But it factors, so we're good. So 2x squared minus 4x plus 3x minus 6. Do the grouping method. If you want to do my shortcut, feel free. Group the first two. What do they have in common? 2x squared and negative 4x. 2x, perfect. So I'm left with x minus 2. What can I take out of 3x and negative 6? Positive 3, and I'm left with x minus 2, which is exactly what we want. So I write my x minus 2 out here one time, and I'm left with 2x plus 3. And then what do I do with each of those two pieces? You set them equal to 0. Perfect. So x equals 2. And x equals, move 3 over, it becomes negative. Then divide by 2, so you have negative 3 over 2. So the way that the question is asked, to find the roots, the solutions, those will be x equals, x equals, x equals. If they say, what are the x-intercepts? How do we always write intercepts, guys? As ordered pairs. So it'd be 1, 0, 2, 0. Whoops, that doesn't look like a 0. And negative 3 over 2, 0. Questions? All right, let's look at the next one. Do you guys have this one next? I did things a little out of order. You'll see. All right, so how many answers are hidden in here? 3. Is it always 3? No, sometimes there's more. And then what am I using to synthetically divide? -5. So I'm going to put -5 over here. And then I have 6, 17, -63, and 10. Bring down that first term and multiply to the corner. 6 times -5 is -30. What's 17 and -30? -13, good. What's -13 and -5? 65. What's -63 and 65? 2. What's 2 times -5? -10. And -10 and +10 is 0. So you proved that, hey, x equals -5 is in fact one of my solutions. The graph will cross the x-axis there. And then what we have left over is our resulting polynomial. How do I write it? God bless you. 6x squared, God bless you, minus 13x plus 2 equals 0. If you wanted to just go ahead at this point and do the quadratic formula, you absolutely could. I'm going to check to see if this factors. Does it? 6 times 2 is 12. Are there factors of positive 12 that multiply to give me positive 12, but add to give me a -13? Yes, x minus 12 and x minus what? 1. Okay, good. I'm doing my shortcut here just in case some of you still like to do that. Now, I found out it's -12 and -1, but what do I have to do with this 6? I have to, where? I have to divide each term by that. If you do not understand that trick yet, don't do it. Do the grouping method. 12 divided by 6 is going to leave me with x minus 2. 1 doesn't divide pretty by 6, so we just move this to the front as a coefficient. So 6 minus 1 equals 0. And then can I go ahead and solve these two? Yeah, if you guys just wanted to write x equals 2 and x equals 1/6, I'm fine with that. If it helps you to actually move the add 1, divide, whatever, but I'm fine if you do it that way. So here are 3 x's, our zeros, our factors, our roots, our solutions. How would I write them as x-intercepts? Yep, -5, comma 0, 2, comma 0, and 1/6, comma 0. Questions? It's fairly simple, right? Comes a little repetitive, I get that. Okay, so now we're going to talk about something called the rational root theorem. All right, this is also referred to as P over Q sometimes. All right, how do we find all of the possible roots? We're going to first just worry about finding all the possible roots, then we're going to find all the roots, and I'll explain to you what that means in a second. But how do you find all the possible roots? There's going to be some questions on WebAssign today that says find all the possible roots, where all you have to do is just list what it could be. There is no plus or minus button on WebAssign, so you have to write +1/2, -1/2, +6, -6, whatever. But the first thing you do is put the polynomial in order of descending degree. What does that mean? Descending degree. Highest to lowest, thank you, exponents. Then to find the possible roots, you always put a plus or minus because it could be a positive or a negative. And it's the last term over the first term. It's the last term over the first term. And what we're going to do is synthetic division, sometimes 2 or 3 times, sometimes just once if we get lucky, but to figure out what could possibly help us find our zeros. So let me explain this to you, okay? Here is a question that says find all the roots. How many zeros do you know are in this problem? There's 3. Can you just look at this? The first thing we should always try to do is factor it. Can we factor this? No, it's not a trinomial that'll break into 2 binomials. It's not a quadratic that we can use the quadratic formula. So this is where you have to do the rational root. You have to do the P over Q. So what's going to happen is you're going to take the last term, which is what? And don't worry about if it's positive or negative. That doesn't matter. And you're going to put it over the first term. So it's 5 over 1. Correct? And we put a plus or minus in front of it. So what are all the possibilities that you could have? Plus minus what? 1, and plus minus 5. Those are the only 4 options that we have here as real whole solid roots. That's it. It's the last term over the first term. So on WebAssign, if it said list all the possible, you would say 1, -1, 5, -5. There's no plus or minus. So what we're going to do, and it's not, this isn't a specific science. You guys can do what you want. I always start with 1, and I synthetically divide. If 1 does not give me a remainder of 0, then I try -1. Then I go to 5, then I try -5. If you jump all around, it's not the greatest thing in the world. So let's just try 1. Let's plug it. Let's do synthetic division with 1. And if I get a remainder of 0, what does that tell me? It is a factor. Yes, ma'am. On the test, I don't care. I'm just saying that WebAssign is asking you for, they don't have a plus minus button. So let's write our coefficients. I have 1, then what? 4, then what? 0, perfect, and -5. Why is there a 0? Because there's no x to the first power, perfect. So let's synthetically divide, see what happens. Bring down the 1. 1 times 1 is 1. 4 plus 1 is 5. 5 times 1 is 0 plus 5 is 5 times 1 is -5 and 5 is. What did you guys just prove? This graph crosses the x-axis at x equals 1. If you did not get 0 then that means, oh, 1 doesn't work. I try something else. So what is left over here? How do I write that? X squared plus 5x plus 5 equals 0. Now at this point, we hope what happens? We hope it factors. Does it? No. What are your 2 options? If you get here and this doesn't factor, what are the 2 ways you can solve this? Complete the square or quadratic formula. I'm just going to go ahead and use quadratic. So A equals 1, B equals 5, C equals 5. Guys, please make sure you know the quadratic formula. Some of you on your quiz messed up your signs. So it's -b plus or minus b squared. So 5 squared. What's the sign in the middle here? Minus 4 times 1 times c, which is 5, over 2 times what? Perfect. So now let's simplify. -5 plus or minus 25 minus 20 over 2. You guys agree? So this equals -5 plus or minus the square root of 5 over 2. Is that a possibility on a graph? Yeah, that's a real place on a graph. Is it beautiful? No. If you want to leave it just like this, that is fine. Those are your 3. I have 2 solutions here, and I have 1 here, right? If we were asked to find the x-intercepts, we would say 1, 0. And what would the other one be? -5 plus or minus the square root of 5 over 2, comma what? 0. If they ask you on WebAssign for intercepts, there is no plus or minus. So you'd have to write -5 plus root 5 over 2, comma 0. -5 minus root 5 over 2, comma 0. How do we feel? All right, let's look at number 7. What's the first thing we should do? All right, let's survey what we have going on here. How many answers are hidden in here? 3. All right, so look to see. Just maybe this factors. Does it? No. If it was squared, would it? Yes, but it's not squared, so we can't. So what you have to say, we have to find all the possible solutions. It's 3 over what? Okay, so guys, what are the factors of 3? What times what gives you 3? So the only possibilities here are 1 and 3. When does this get a little more? When you have like the last number being 16. So you have 1, 16, 2, 8, 4. You know, it just becomes a little more. All right, so let's try 1. Let's see if 1 is a factor here. So I'm going to write out my coefficients. What are my coefficients? 1, 0, 2, -3. Perfect. Bring down your 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 2 plus 1 is 3. Good. 3 times 1 is 3. -3 and 3 is Okay, cool. We love when whatever the first number is that we try works. So what's left over, guys? How do I write it? X squared plus x plus 3 equals 0. All right, I have 2 more answers that I have to discover. Does this factor? No. So what are my 2 options again? Quadratic or completing the square. I'm just going to go with the quad. So I get negative b, negative 1 plus minus 1 squared minus 4 times 1 times 1 all over 2 times 1. No, not 1. Yeah, it should be 3, sorry. I realized after I wrote it. Okay, keep going. So negative 1 plus or minus 1 minus 12 over 2. Negative 1 plus or minus, what do you guys notice here? It's imaginary. All right, keep simplifying. Keep simplifying. This is negative 1 plus or minus I root 11 over 2. So, guys, this is where you have to be careful. How many solutions are there to this problem? Not how many real solutions. How many total solutions are there? 3. 2 of them are imaginary and 1 is what? Real. So if they asked you to write your answer as x-intercepts, what is the answer to that question? Just 1, 0. Because x-intercepts are real. If they ask you for all the answers, all the solutions, it's the real and the imaginary. If they ask you for the real ones, it's just the ones that cross the x-axis. Does that make sense? Yes, sir. Because 1 worked. Yeah. All right. Go to this one. It's not next in your slide, right? Okay. Number 8. How many answers are hidden in here? 5. You guys just can't group this. You can't say, oh, okay, I got it. What we have to do is say, oh, I got to use the rational root theorem to find one of my answers that's hidden in there. There is something hidden in there that I have to find. So how do I figure out which numbers I should use to possibly synthetically divide? I should do plus or minus the last over the first. So in this case, we have a few more factors that we have to deal with. What gives you 8? 1, 2, 4, and 8, correct? Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. So when they ask you on WebAssign, or if they ask you on the test, what are all the possible zeros? That's how you figure that out. That's how you figure that out. All right, so let's talk about this. I always start with 1. If 1 doesn't work, I go to negative 1. If negative 1 doesn't work, I then go to 2, which is whatever. When I say doesn't work, it means when you synthetically divide and you don't get 0 as an answer. So here we go. What do I do? How do I synthetically divide here? 1, what? 0, good. 1, 2, negative 12, and 8. Okay, perfect. So I bring down my 1, and then I say 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 1 plus 1 is 2. 2 times 1 is 2 plus 2 is 4 times 1 is negative 12 and 4 is negative 8. Ooh, what's negative 8 and 1? What's negative 8 positive 8? Oh, I love when that happens. So I just discovered that x equals 1. My graph crosses the x-axis at 1. Yeah? Okay, so write your resulting polynomial. You guys are doing great. What's my resulting polynomial? I start off with x to the 5th, so what am I left with? X to the 4th plus x cubed plus 2x squared plus 4x minus 8 equals 0. Well, guys, all the other ones that we had before, we could just factor at this point. Can we group this? Can we factor this? No. So what do we do? Can't group it. There's 5 terms, so we can't group it. You got to do it again. Yep. Perfect. we're just going to do synthetic division again. So we're going to take the last term over the first. Good, Maria. Again, guys, don't worry that the last term is negative, then it was positive in the front. It doesn't matter because you're using plus minus. So again, what are all the factors of 8? Well, plus minus 1, 2, 4, and 8. You might have to do synthetic division more than once. That's okay. So let's go ahead and write out our coefficients. I'm going to use 1. So 1, 1, 2, 4, negative 8. You guys with me? Okay, so bring this down. 1. 1 times 1 is 1. 1 plus 1 is 2. 2 times 1 is 2. 2 plus 2 is 4. 4 times 1 is 4. 4 plus 4 is 8. 8 times 1 is 8. Negative 8 positive 8 is 0. So you found out what? That x equals 1. Are you allowed to have the same answer twice? Yeah, that's fine. That's called multiplicity. We'll talk about that after Christmas. What that tells you is that at that point, it doesn't go through the x-axis. It touches the x-axis and bounces in the other direction. But we'll talk about that. So there's 2 of the answers that we found. We have x equals 1 twice. It's called multiplicity. So what are we left over with? How do I write this? Tell me. X what? X cubed plus 2x squared plus 4x plus 8 equals 0. Now, guys, at this point, whenever I have x cubed or x squared, I always try to factor. But if you didn't recognize that you could factor this, you could group it, could you do synthetic division again? Yeah, absolutely. You could do the factors of 8 again, do synthetic division, and you would discover the next root. But we want to work smarter, not harder. I'm going to go ahead and group here. I'm going to see if these two group. If they didn't, no big deal. You just do synthetic division again. But what do x cubed and 2x squared have in common? X squared. Okay, so I take out the x squared. I'm left with x plus 2. Agreed? Okay, what can I take out of 4x and 8? 4. So x plus 2 equals 0. So x plus 2 comes out in front once. And then I have x squared plus 4 equals 0. Can I now just set these both equal to 0 and solve it? Sure. So over here I have x plus 2 equals 0. So I got x equals what? Negative 2. I'm going to stop you for 1 second. If you guys, at this point right here, if you said, oh, I'm just going to go ahead and do synthetic division again, when would the root become available? What number would have, quote unquote, worked with synthetic division? Negative 2. You would have done 1 and your remainder wasn't 0. You would have done negative 1, the remainder wasn't 0. You would have done 2, the remainder wasn't 0. And then you would have done negative 2 and gotten a remainder of 0. So you still would have found the same answer. It's fine if you did it that way. Now, what do we notice here? When I set this, x squared plus 4 equals 0. This becomes x squared equals negative 4. I take the square root, and what is the answer here? Plus and minus what? 2i. So let's talk about our answers here. I have x equals 1, 1, negative 2, 2i, and negative 2i. How many of these are real? 3. And how many of these are imaginary? Okay, so I have a total of how many solutions? How many answers? 5, which is what we said at the beginning. How many of these are actually on a graph? 3. What are the ones that are on the graph? 1, 1, and negative 2. These are my x-intercepts. Do you guys understand that? There's 3 real solutions. There's 3 real places this graph touches the x-axis. The other ones are imaginary, so which means it just kind of goes up and down like a little hump, either above or below the x-axis. All right, so on WebAssign, they're going to ask you 3 kinds of questions. Like you might have this. I have one more example to do, but you might have like 6x to the 9th plus 7x squared. How many zeros are there? How many zeros? There's 9. There's 9 answers. How did you know that? Highest exponent. If they tell you to list the possible, that's going to be the plus minus 1, 2, 4, 8, whatever. You might have to list, you have to list it as like positive 1, negative 1. Positive 2, negative 2. There's no plus minus. And then you're going to have some where you actually have to solve it. Yeah. Yeah. Okay, let's look at this last one. Go over this with you guys. Wait. Okay, this is the same type of problem. All right, same type of problem. How many answers are hidden in here? There's 4. Can you guys just group this? No, we can't just put it into a trinomial. So we have to do what? What's our last resort? The P over Q. The last over the first. First over the last. Which one? Last. You can list it out like that. So it's the last plus minus 2 over plus minus 6. This is where things get a little harder when the first term, the leading coefficient, isn't 1. When it's 1, it's pretty simple. When it's not 1, and you have to list all the possibilities, all right? This is just where you have to think just a little bit. Well, how many possibilities do I have in the numerator and how many in the denominator? It's not just 1 in your denominator anymore. So the way that you would list out all your possibles, all right? What are my possibles for 2? Okay, plus minus 1 and 2. What are my possibles for 6? 1, 2, 3, and 6. You have more possibilities now, guys. The easiest thing to do is almost like a little flow chart. To take 1 and put it 1 over 1, 1 over 2, 1 over 3, 1 over 6. What I mean by that is go plus minus 1 over 1, which is what? 1. Then you have plus minus 1 over 2. Then you have plus minus 1 over 3. Then you have plus minus 1 over what? 6? Okay. You guys agree with that? Okay, so now we're going to do the same thing with 2. And you might have some overlaps, which is fine. But what do I have with 2? 2 over 1, which is 2. Plus minus 2 over 2, which is what? 1, so I don't have to write that again. Then I have plus minus 2 over what? 3. Good. Then I have plus minus 2 over 6, which is the same as 1/3. So do I have to write that one again? No. Does everybody understand what I just did there? I took the first number and I put it over everything in the denominator. Then I took the second number, put it over everything in the denominator. If you have one that repeats, you don't have to write it. So how many possibilities do I have here? 2, 4, 6, 8, 10, 12. In this case, there's 12 possibilities. You are going to have questions on WebAssign that ask you to list out the possibilities. You have to do this. There's one, I think, that's kind of long. It's not, you don't have to do the whole problem. You just have to list out the possibilities. So you would say 1 and negative 1. 1/2, negative 1/2. 1/3, negative 1/3. So now, guys, yeah. Because there's 2 here, 2 here, 2 here, 2 here, 2 here, and 2 here. So now let's use synthetic division. Let's hope that 1 or 2 works and we don't have to use a fraction. So let's just try 1. I'm going to start with positive 1. What are my coefficients? 6, 7, negative 12, negative 3, and 2. Perfect. All right, bring down your first term and let's go. What is 6 times 1? 6. 6 plus 7 is 13. 13 times 1 is 13. Negative 12 and 13 is 1. 1 times 1 is 1. Negative 3 and 1 is negative 2. Negative 2 and 1 is negative 2. What'd you guys just find out? Awesome. That is so helpful. I know that x equals 1. So what do I have left over here? Tommy, 6x cubed plus 13x squared plus minus equals 0. All right, I have 4 terms. What do we hope happens when we have 4 terms? We hope we can do what? Group, okay. Guys, is this going to group? No. Marie said, we can't. Jesslyn said, are you serious? So what does that mean? What do we have to do? We got to do synthetic division again. So list out again the possibles. What do you notice about this problem? It's the same numbers. So do we really need to go through and list them all out, or can you guys just rewrite your list? All right, we can just rewrite the list. 1 plus minus 1/2 plus minus 1/3 plus minus 1/6 plus minus 2 and plus minus 2/3, right? Okay, it's unfortunate, but that's okay. All right, let's go ahead and find our next lovely root. I'm going to start with 1. What are my coefficients? 6, 13, 1, -2. Bring down your 6. 6 times 1 is 6. 13 plus 6 is 19. 19 times 1 is... Guys, is this going to give me a 0? No, because 119 is 20. This isn't going to work. So what's the next number we should try? No! -1. Don't just jump around. Yes, do the whole numbers first. But let's try -1. So 6, 13, 1, -2. Bring down your 6. 6 times -1, -6. 13 and -6. 7 and -1. Ugh. Does this work? No! All right. Don't worry about a fraction. Don't worry about the fractions. Now let's try 2. Let's try 2. 6, 13, 1, -2. Bring down your 6. 6 times 2 is 12. 12 and 13 is this going to work? No. So abandon ship. Let's try -2. And then if that doesn't work, we'll go to the fractions. So 6, 13, 1, and -2. 6 times -2, -12. 13 and -12, 1. 1 times -2, -2. What's 1 and -2? -1. What's -1 and -2? Woo! What happened? Yay, it works. So what else did we find is a solution? X equals -2. So we know this graph crosses the x-axis at 1 and -2. Now what do we do with our leftovers? 6x squared plus x minus 1 equals what? 0. All right, at this point, there's 3 options. We hope that this factors. If it doesn't factor, complete the square of the quadratic. Does this factor? Are there factors of -6 that multiply to give me -6 and add to give me a 1? -2 and 3. Perfect. So 6x squared minus 2x plus 3x minus 1 equals 0. Group the first two. 6x squared and -2x. What can I take out? 2x. Now so 3x minus 1. What can I take out of the next group? Positive 1. So I have 3x minus 1. So we have 3x minus 1. And then we have 2x plus 1. So here I have x equals positive 1/3. And here I have x equals -1/2. So guys, if you were doing your synthetic division, right, and you didn't want to do just the whole numbers, would synthetic division giving you a remainder of 0 if you use positive 1/3? Yes. Would you have gotten a remainder of 0 if you used -1/2? Yes. So how many answers do we have for this question? 4. How many did we say we were going to have at the beginning? 4. So good. Check yourself. Is that positive or negative? So 1, -2, positive 1/3, and -1/2, correct? All of these are what? They're all x-intercepts. They're all real. This graph crosses the x-axis how many times? 4. Because it only has each one time, there's not the same one twice, it's going to go through the x-axis each time. We'll talk about that after Christmas. So if I were going to write my intercepts, it's 1, 0, -2, 0, 1/3, 0, and -1/2, 0. Now, is that like the greatest problem in the world? No. But don't get frustrated, guys. Don't try to go too fast. Take your time. You guys will be fine. Website is not due until Thursday morning. So if you guys want to work on it tomorrow in class with each other, ask me questions, that's perfectly fine. If I were you, I would look at it tonight, just so you kind of get a little head start.